Okay, we're back. We are still on page 1 of Notes 24, and we just did some problems where we're verifying solutions. The next problem that we're going to do is really similar, but instead of verifying a solution, we have sort of like we have a solution, but what we want is we want to figure out what value of A will allow this differential equation to be the equation that this is the solution of. There's almost certainly a better way to have said that. You know what we want to do? We want to find the value of A for which A times x double prime plus x prime plus x equals 0. That's what we want to do. That's probably the better way to say it, the way the problem was written. So let's see if we can do that. So the key step is, well, it's not the key step. The key thing here is be really organized when you find your derivatives, especially e to the negative t is going to introduce a negative sign. The derivative of cosine is going to introduce a negative sign. There's a lot of negative signs in here. So let's be really careful while we do it, but we're going to need, to be able to do this successfully, we need to know what x double prime is, which we don't. We'll need to know what x prime is, which we don't. And we'll need to know what x is, which we do. So far we're 1/3 of the way to being able to start the problem. So let's do it. Let's find x prime. So x prime of t. So you want to be really organized, which is not always like, that's not exactly my wheelhouse. So first is e to the negative t times the derivative of cosine is negative sine of t plus second, which is cosine of t, times the derivative of e to the negative t is negative e to the negative t. Okay, so I think that that's going to simplify to x prime of t is, I'm going to take out negative e to the negative t, because you can, so why not? And then sine of t plus cosine of t. And I feel pretty good about that. Like, I think that's right. So that's x prime. So we're going to substitute that ultimately into our equation. And now we need x double prime. So that's part of why you want to factor these things. If you don't factor them, finding the second derivative is so much harder. X double prime. It just requires more product rules, which, you know, is fine if you want to do it. First, the derivative of the second. So the derivative of sine is cosine. The derivative of cosine is negative sine. Okay, and then plus second, which is sine plus cosine, times derivative of the first, which is negative e to the negative t. Okay, so what can we take out? Well, we can definitely take out negative e to the negative t. Did I mess that up? Because that seems, so it's first is negative e to the negative t. Derivative of the second is cosine minus sine. Sure. Plus second, which is sine. And then derivative of, oh, the derivative of negative e to the negative t. I did mess that up. I thought it looked like a little too, I don't know, simple or something. So there shouldn't have been that extra negative. So the derivative of negative e to the negative t is positive e to the negative t. All right, so what are we doing? We're going to take out e to the e to the negative t. E to the negative t. What are we left with? All right, so we will have a, I guess I'll try to underline. So keep in mind in the first thing, there's a negative that's just kind of like sitting there. So we'll have a negative cosine. And then from the second thing, we'll have a positive cosine. So the cosines are gone. And that's probably good. And then for the second thing, we'll have a, because the negative's still sitting there, we'll have a positive sign and then another positive sign. So I think we're left with two signs. So 2 sine of t. And then I think I'm going to rewrite this again because you really want these to look like as nice as possible when you do these. So I'm going to say it's e to the negative t. Nope. So I'm going to do exactly the opposite of what I said. So it's 2e to the negative t and then sine of t. I think that that's what it is. It's like I'm inclined, you know what, I'm going to check it on the calculator because if it's wrong, like it just derails everything. You know what, I don't even have the calculator open right now. So I'm going to open the calculator in the background and then when it finally like fires itself up, it takes a little while. I don't know if you've ever done that. All right, so let's think. I'm thinking at least, I can at least go through and like color code. I'm thinking that this is right. And so now what I want to do is I want to make those substitutions. So I'm going to end up with, so where should I do this? How much space do I have over? I have like kind of a lot of space, kind of, but oh no, yeah, everything simplifies really nicely. So I'm going to say that I have a, and then x double prime. So that's 2e to the negative t sine of t. And then plus x prime, which I'm going to, now I'm going to distribute. So I'm going to say it's minus e to the negative t sine of t, and then minus e to the negative t. Am I like way over? Kind of. Cosine of t. Okay, so that's my x prime. So I guess I could color code these also. This was when I substituted for x double prime. This will be when I substituted for x prime. And then I need to add in x of t, so I need more space. I'll put it down here, I guess, because I think I'm going to be able to simplify this. I don't know. I think I'm going to simplify this pretty quickly, but so I need to add in another x, right, which is e to the negative t cosine of t. And then all of this should, according to the differential equation, be equal to 0. So let me highlight this. This was my x. All right, with the caveat that if I got anything wrong, this is just not going to work. But maybe we'll check it on the calculator anyway. Can I check it on the calculator? Probably. So let's see. What do we have going on? So I have 2e to the negative t, 2a e to the negative t sine of t. You know, all right, so immediately right off the bat, I see these cosines are just going to cancel, which is good. So those are gone, because I didn't want to have to worry about those too. And then I can take out e to the negative t sine of t. So I'm going to do that. So e to the negative t sine of t. And then from the first thing, what am I left with? I'm left with 2a. And then from the second thing, oh, well, don't close a parenthesis. From the second thing, I'm actually just left with minus 1. And then that should equal 0. Okay, so our goal, though, is to solve for a, right? So either e to the negative t equals 0, which it doesn't, sine of t equals 0, which there are places where sine of t equals 0, but that's not going to tell us a. If this thing is going to, what value of a will make this equal 0? A would have to be 1/2. So I think that that is my final answer here, that I need a to equal 1/2 for this thing to be true. All right, let's see. I think the calculator is probably awake now. So let's see if I can share it. And then I'm going to try to do this on the calculator. So I'm going to add a calculator page. All right, what to do? I'm going to define a function called x of t, which is always a little risky because now like your x value will be defined. So I do not generally recommend that. But if you do, just start a new problem before you do anything else. All right, and then I need another function, which I'm going to call xp of t. xp, sure. So that's for x prime, and that'll be the derivative. Nope, derivative of, I went one too far there. The derivative with respect to t of x of t. And then I need a second derivative, so x double prime, so pp, I guess. And then use the template. So this is good, gives us a chance to see how this goes. All right, so now I need, let's see what the calculator just does with it. I'm gonna use solve. So I'm gonna do menu 3, solve. All right, so differential equation, a times xpp of t plus x prime of t plus x of t equals 0, and I want to solve for a. I get a equals 1/2 or sine of t equals 0, which is another thing that we knew, but we just disregarded it. Basically, if sine of t equals 0, it doesn't really matter what a is equal to because you'll get 0 anyway. But our issue was we need to solve for a, and we got a is equal to 1/2. Pretty good. You can have the calculator show you what these things are if you're interested in that. But I guess since we got it right, we probably had those right as we went through the problem. So this is a pretty good problem. It's kind of a weird problem. You run into these FRQs, really old FRQs, free response questions. used to have these sorts of problems more frequently, which is probably the basis for this when I wrote it. Uh, but now it's not on it that often. But verifying solutions, finding a value of A for which something is true, like this is still a thing that you need to do. So I'm gonna wrap this up. I'll come back in the next video and I'm gonna start on the next page. So I will see you there.